Hello, welcome to this tutorial where today we are going to tackle a question under surveying module 3 diploma in building, diploma in civil, and diploma in architect. This paper was done on March 2023, so that is our March series. We are going ahead and looking at question number 6, where we were told the table 2 shows reduced levels of a section of a road at changes 150 meters to 850 meters. Using the data provided and the information in table 2, determine the volume of excavation by prismoidal formula. This question carries 20 marks. That is a good question for 20 marks. There we are giving the data. We have the side slopes 1 into 3. We have the traverse slope 1 into 15. We have the formational width 16 meters. Then we have a falling gradient from chain edge 150 meter to 850 meter, having a ratio of 1 to 20. And then on table 2 we are given a table there with 3 columns. On our first column we have the chain edges, then we have the formational level for only one point, then we have the ground level at center line, so that is in meters, so that is the center line of the road. We are given all the ground levels for all the chain edges provided there. Having read that question, you go ahead and we see what we can do and the possible solutions, because here we are only told to determine the volume of excavation by prismoidal formula. Nothing else is given, but on the data we have the formational width, we have the side slope, so we need to calculate the area. We are given a lot of data, and through those data provided we need to find a solution and the best way forward. Let's go ahead and think on the best possible route on which we can tackle this question. I came up with a simple solution because I think that we had some freedom. I'm not sure that is a freedom or that was really the thing that they needed you to calculate, but I calculated all my areas, then later did my volumes. First of all, from the falling gradient from chain edge 150 meters to 850 meters, we were given a ratio of 1 to 20. And by giving me that ratio, I go ahead and on my formational levels were less than the ground level, I go ahead and apply the concept taught in setting out of a road. That means I'm going to use the formational level as my event level, and the falling gradient is what is going to show me where I will be heading to. On the 150 meter chainage, there our formation level was already given as 1650. Then we go ahead and chainage 300. We don't have the formational level. I go ahead and use the formational level provided to me on the chainage of 150 meters and multiply the falling gradient by the distance between those two. So the difference in distance between the chainage of 150 to 300, that is 150 meters, that is the value that I'm going to multiply. So I go ahead, that is 1650 minus, because this is a falling gradient, minus my ratio, so that is 1 over 20 times 150, getting my answer as 1642.5. I go ahead and use that data to the next chainage, and my next chainage has a difference of 150 meters. I do the same. I use the formational level that was found on the 300 meter chain. That is 1642.5 minus 1 over 20 times 150, getting my answer as 1635 meters. I go ahead, the difference between my 450 meter chainage and 650 meter chainage, that is 200 meters. That is the distance I'm going to cover there. So we are having the formational level of the previous 1635 minus 1 over 20 times 200, getting my answer 1625. On the last chainage, 850 meter, the difference between that and the previous was 200 meters. So I use my previous formational level, 1625 minus 1 over 20 multiplied by the distance of 200, getting my final answer as 1615. I went ahead and saw my best possible solution of calculating the area, and I used the method of the crossfall. So that is calculating the area of sections. So that is under the crossfall. And under the crossfall, so best, because the data given to me there, we had the side slope and the transverse slope. We had the formational width. That means all that I'm looking for are provided there. When calculating crossfall, first of all, you have to find the side width, that is W1 and W2, and the formulas are there on the screen. The same, after doing that, the final formula for calculating the area, that is 1 over 2 m, that is the side slope, into bracket, that is b over 2, and b, that is the formational width, plus m, h, that is the height difference, and then multiplied by the addition of W1 and W2. Then we subtract b squared over 2. There, my b, that is the formational width, that is 16 meters. M, that is my side slope, that is 3. And k, that is my transverse slope, that is 15. Earlier we had calculated the formational level of all our chainages. So I go ahead and subtract the formational level from the ground level, and that difference gives me the height. So that is the height difference between the ground and the formational level. I had done all those formational level, so I first start with the first one. It is provided in the table there, that is 1657.32 minus 1650.53, getting our answer 6.79. We go ahead and we do for the next, that is 1656.89 minus 1642.5, getting our height difference as 14.48. On the next, the ground level, that is 1657.08 minus 1635, getting our answers 22.08. We do the second last, that is for the 650 meter chainage, that is 1657.31 minus 1625, getting our answer as 32.31. On our last there, we have 1656.8.98 minus 1615, getting our answer as 41.26. 0.98. So that is the height difference between those all changes given to us there on the question. I go ahead and calculate the area of the first chainage. First, we start with the side width, and my b, that is 16 over 2 added by the multiplication of 2, that is 3, multiplied by the height difference of 6.7. We close the bracket. Then we multiply 15 over 15 minus 3. We close our bracket, getting our answer 35.463. W2 the same is done, but on our last side there, that is k over k plus m, so we change that sign to addition. You can do that. My calculator is doing this sums directly, but that is a programmable scientific calculator. But for normal calculators, please observe and do these calculations separate in order for you to get the correct answer. So the scientific calculator, when you input these values, they go directly. That my answer becomes 23.642. And then my area, that is 1 over 2 times 3 into bracket b over 2, that is 16 over 2 plus 3 times 6.79, and then the same is done, that is 35.463 plus 23.642, and our final answer, we subtract 16 squared over 2. My area 1 becomes 258.135 meters squared. We go ahead and calculate area 2. So I hope you are getting the concept. So we have to do for all the areas for the all chainages. There are 5, so those were 5 chainages. So we have to calculate areas under all those there by the method of crossfall. So the same is done on area 2, area 3, area 4, and the last area 5. There are getting our answers. So this is just a simple calculation, and if you are doing it with the scientific calculator, it becomes more easy and more simplified than the other normal calculators. So let's go ahead and we calculate all those areas. After having done the areas, we go ahead and apply the formula for excavation by the prismoidal method. So we have two different ways. So in all my other videos, I have been using the first formula, that is V is equals to D over 6 into area 1 plus 4m, m that is the mean of those two areas, plus area 2, or V is equals to 2D over 6 into brackets area 1 plus 4 area 2 plus area 3. We close our bracket. Today we are going to use the second formula. It's much simplified, it is much easy because this question has, we have done a lot. So let me use a more simplified way, but both our answers will be, so our answer will near be the same. So let's go ahead and we do. In this question, I've used these two formulas because as you can observe from the table in the question, our difference in the changes, they were a little bit different. So we didn't have a constant interval. There we had two separate intervals, an interval of 150 and the other of 200. So we could not have used the general formula for prismoidal. So that's why I'm applying this. More so this is the before the formula was advanced. So this is where the formula was derived from. Let's go ahead and we calculate our volumes. First of all, let's do for V1, that is 2D, 2 times D, that is the difference in the dimensions or the intervals, that is 150 over 6 into brackets our first area that we had calculated before, then plus 4 the second area that we are calculating, then our last, that is area 3. That is area 3. Getting our total answer as 287 and 23.45 meters cubic. I will go ahead and we do for volume 2. That is 2 multiplied by the difference. So that is the difference in the, I'm using a pair of three areas. So in our other last 3 areas, the difference between those 3, we had an interval of 200. So that is over 6 into brackets area 3 plus 4 area 4 plus the last area 5. By the use of the calculator, our answer becomes simplified. So getting our answer as 1,553,809.467 meters cubic. That is my answer. After having done that, I combine the two volumes because I need to find the total, and by adding the two volumes, my final answer becomes 1,832.917 meters cubic. So that is more simplified calculation, more simplified method. You can try to do the same using my first formula and to see if you get an answer similar to the one that I've done. You can calculate using the calculator. So let's go ahead and we do that to see our final answer if it will tally, but that answer will need to be near what we have gotten now. So the difference between those two answers will need to be minimal. Let's go ahead and we observe that. Having done that, we have come to the end of our lesson. You can put more practice and we see each other when another question will come across it. Thank you. Don't forget to subscribe to the channel for more lessons later.